Hello everyone. Now I will introduce the paper Satellite Traffic Forecast based on multi-dimension. This is a paper about traffic prediction and machine learning. Now let me briefly introduce the background of the research in this paper. With the development of satellite networks and the increase in business requirements such as Starlink and Kuiper, it is a challenge to better provide high-quality service to users. The accurate prediction of end-to-end traffic can contribute to the realization of congestion controls, resource allocation, and anomaly detection. Let's summarize. And now let's introduce the previous worker, which is mainly divided into linear algorithms and nonlinear algorithms. Linear algorithms mainly include autoregressing moving average and autoregressing integrated moving average, and the hot winter algorithms, which are simple to implement and have better accuracies in simple environments. Nonlinear machines are mainly about neural networks, among which the more commonly used are support vector machines, the RNNs, and the LSTM, and the autoencoders. Compared with linear algorithms, nonlinear algorithms can adapt to more complex environments and have better processing capabilities for nonlinear characteristics of data. However, the previous workers had an obvious disadvantage. They only considered predicting the traffic at the next moment based on the short period sequence and ignored the long period characteristic of the traffic. Through the analysis of the dataset, I found that the network traffic had obvious daily period characteristic similar to the morning peak and evening peak of ground traffic flow. And this picture shows that the traffic codes of a random node matured from the dataset for a week, and the red circles represent the current peak traffic moment, and it can be seen that the daily peak traffic of this week appears between 20 o'clock and 23 o'clock. So based on these features, that we know that the flow date has obvious periodic characteristic and the offset. Therefore, we propose a model that can consider both the short period and the long period characteristic of traffic. As shown in the figures, our model is divided into three parts. The part A is used to extract short period figures, and the input sequence is the sequence adjacent to the prediction time, and a short period prediction value, the little k in red circle, is the output. The part B is extraction of long period features, and the input is the traffic sequence at the same time every day in the past week as the predicted time, and the predict values on the first layers and can obtained through the LSTM, and then the attention mechanisms is introduced, and the first layer predict values is weighted and summed so that we can obtain the final long period sequence, and through the GRU we can obtain the final, and we can obtain the long period prediction value, and this is the little y in red circles. And the part C is the joint prediction part, which connects the short period predicted values, the little k, and the long period predicted values, the little y, through a fully connected layers and outputs the final predicted values, the out, in the black circles. Next, let's introduce the experiment of the papers, and which is mainly divided into two parts, the dataset and hyperparameters. Because the satellite's traffic dataset is difficult to obtain and the simulation dataset lacks the random characteristic of user operation, so we look for the traffic dataset similar to the satellite network in the ground dataset. The dataset used in this paper is Abelian, which is an early backbone network with 12 nodes and 50 edges, as can be seen from the topological map on the right. Abelian has a certain similarities with satellite networks. On the one hand, the distance between the nodes is far apart, and on the other hand, the connection relationship between the nodes is similar to that of the satellite constellation. Therefore, if the inflow and the outflow data of each node is viewed as the data upload and received by the ground node, the research on Abelian can serve as a reference for future satellite traffic prediction research. And in the dimension of the dataset, we use 64% of the data as the training set and 16% of the data as the validation set, and the 20% of the data as the test set. And in the hyperparameters, in the temporal parts, the length of the short-term LSTM set to 15. That means we're considering the previous 75 minutes, and in long-term periodical information, that means the part B and the big P is set to 7. That means considering the previous 7 days, and the big Q is set to 7 too, and that means we're considering the 15 minutes before and the after of the predicted time, and the time interval is 5 minutes in a day. And the hidden elements or unions of LSTM is set to 16.4, and the optimizers is atoms, and the batch size is set to 16.4, and the learning rate, and we choose is the 0.0001, and we also use the dropout and the early stopping. So the dropout we set is the 3.3. The finals, the training epicals we set is the 500. In the result part, we carry out two parts. The first is the traffic metric prediction and the single node traffic prediction. From the left figures, we can see that compared with the previous algorithms, that the armies, the SVMs, and the LSTMs our models have better performance in metric predictions, and in the right tables, we can see that in different single-node traffics, our models compared with the LSTMs also have different improvements, and among those, there is a bad improvement in the flow sequence with the relative large fluctuations. And regarding to the future workers, on the one hand, to obtain more realistic and effective satellite traffic datasets. We all know that the models based on real datasets are more effective, and on the other hand, satellite networkers have time-varying topologies, but the ground datasets cannot reflect these features. So therefore, these papers do not consider the special characteristics and the topological changes of traffics, and hopes to add this part in future work. Thank you.